a real life problem. So you have you're given the shape of a tidal wave. It's modeled by a sinusoidal function, such as this one. The picture is this one. You have a certain wave. This is going between. This is oscillating between -5 and 5, and we assume that this is giving us the height of the tidal wave at time t. So and 0 is the average sea level, and we suppose this is in feet. So our graph is going to be something like this. So this would be 5 sine of t pi over 12. And then if we want to account for the phase shift, then we have to find out how it's shifted. So this is shifted to the left by pi over 3. So actually the tidal wave doesn't look like this. It looks like this, something like this. Actually, okay, it's shifted by less than pi over 2, so the peak actually happens a little bit after. Okay, so now this one is 5 sine t pi over 12 plus pi over 3. Oh my goodness. Okay, we don't actually need to know, for this question, we don't need to graph these functions. These functions are tricky to graph just without the calculator. So you usually, in a normal situation, just use the calculator. What you want to know, though, is the following question. You want to know when is the level of the tidal wave bigger than 4. So for which period of time is it bigger than 4? The tidal wave goes to up to 5 feet, so it floods it goes over your flood barrier. And when is the tidal wave over? It's when this is over. Okay, when this is over. So what you need to do is you really have to find the intersection of your sine graph with this vertical line y equals 4, with this horizontal line y equals 4. In other words, you need to solve the equation 5 sine of t pi over 12 plus pi over 3 is equal to 4. You will get two solutions. One solution will be this t1, the other solution will be this t2. We'll get two fundamental solutions. T1 and T2. And the period of time tidal wave is above is the difference. So T2 minus T1. So we need to solve this equation. So we have 5 sine t pi over 12 plus pi over 3 equals to 4. So sine of this thing equals to 4 over 5. So this is t pi over 12 plus pi over 3. So t pi over 12 plus pi over 3 is equal to arc sine 4 over 5, or pi minus arc sine 4 over 5. That's because when you're solving sine equals to 4 or 5, you take this number, that's 0.8, you take this number 0.8, you draw a vertical line, and you find two angles that have this sign. This is your angle x1, and this is your angle x2. And the angle x2 is equal to pi minus x1. So that's x1, and this is x2. And then you need to solve for t. So you'll have pi over 12t equals to x1 minus pi over 3, or pi over 12t equals pi minus x1 minus pi over 3. And therefore t1 is equal to 12 over pi x1 minus pi over 3, or t2 is equal to 12 over pi, and this is pi minus pi over 3 is 2 pi over 3 minus x1. So we need the difference, t2 minus t1, so that's 12 over pi, 2 pi over 3 minus x1, minus 12 over pi, x1 minus pi over 3. So that's 24 pi over 3 pi minus 12 over pi x1 minus 12 over pi x1 plus 12 pi over 3 pi. So 24 pi over 3 pi is 8, 12 pi over 3 pi is 4, so 8 plus 4 is 12. So 12 minus, and then I sum these two, this is twice 12 over pi, so 24 over pi x1. So this is 12 minus 24 over pi, and the x1 was arc sine 4 over 5. So making sure that you actually are working in radians, you would plug this expression in the calculator and you would get the numerical answer. But leaving it as it is perfectly acceptable.